Class 10 Science Chapter 3 Metals and Non-Metals. Physical properties of metals. I. They are lustrous, i.e., they have a shiny surface. 2. All metals are solids except mercury, which is liquid at room temperature. 3. Metals are ductile, which means they can be drawn into wires. 4. Metals are malleable, which means they can be beaten into sheets. The only exception is mercury. They are good conductors of heat and electricity except lead and mercury. 6. They have high density and high melting point except alkali metals like lithium, sodium, potassium are so soft that they can be cut with a knife. Physical properties of nonmetals. I. They are non-lustrous and have dull appearance except graphite and iodine that are lustrous. 2. They are generally soft except diamond. 3. They are non-ductile. 4. They are non-malleable. They are poor conductors of heat and electricity except graphite, which is a good conductor of electricity. Six. They have low density and low melting point except diamond, which has high melting point. Chemical properties of metals. I. Metals react with air or oxygen to form metal oxide. Example: 2Cu plus O2 gives to CuO. 4Al plus 3O2 gives to Al2O3. Metals such as potassium and sodium react so vigorously that they catch fire if kept in the open. Hence, to protect them and to prevent accidental fires, they are kept immersed in kerosene oil. Amphoteric oxides. Some metals such as aluminium oxide, zinc oxide can react with both acids and bases to produce salt and water. Such oxides are known as amphoteric oxides. Al2O3 plus 6HCl gives to AlCl3 plus H2O. Al2O3 plus 2NaOH gives to NaAlO2 plus H2O. 2. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis, metal hydroxides. Example: 2Na plus 2H2O gives to NaOH plus 1H2. 2Al plus 3H2O gives Al2O3 plus 3H2. Metals like potassium and sodium react violently with cold water. The reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. 2K plus 2H2O gives to KOH plus H2 plus heat energy. 2Na plus 2H2O gives to NaOH plus H2 plus heat energy. The reaction of calcium with water is less violent. Calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Ca plus 2H2O gives CaOH 2 plus H2. Magnesium does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminium, iron, and zinc do not react either with cold or hot water, but they react with steam to form the metal oxide and hydrogen. 2Al plus 3H2O gives Al2O3 plus 3H2. 3Fe plus 4H2O gives Fe3O4 plus 4H2. 3. Metals react with dilute acids to form salt and hydrogen. Example: Mg plus 2HCl gives MgCl2 plus H2. Reaction of metals with solutions of other metal salts. Reactive metals can displace less reactive metals from their compounds in solution or molten form. Fe plus CuSO4 gives FeSO4 plus Cu. Cu plus 2AgNO3 gives CuNO3 plus 2Ag. Special cases. Asterisk metals such as potassium and sodium react so vigorously that they catch fire if kept in the open. Hence, to protect them and to prevent accidental fires, they are kept immersed in kerosene oil. Asterisk at ordinary temperature, the surfaces of metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of oxide. The protective oxide layer prevents the metal from further oxidation. Asterisk iron does not burn on heating, but iron filings burn vigorously when sprinkled in the flame of the burner. Asterisk copper does not burn, but the hot metal is coated with a black-colored layer of copper, 2 oxide. Asterisk silver and gold do not react with oxygen even at high temperatures. Chemical properties of nonmetals. I. Nonmetals reacts with oxygen to form nonmetal oxide. S plus O2 gives SO2. C plus O2 gives CO2. 2. Nonmetals do not react with water and acids. Reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing activities. Formation of ionic compounds. Compounds formed due to the transfer of electrons from a metal to a nonmetal are known as ionic compounds. Here, metals get positive charge on losing electrons and nonmetals get negative charge on gaining electrons. The bond formed between such positive and negative ions is called ionic bond. Example, sodium and chlorine react with each other to form sodium chloride. Properties of ionic compounds. I. Ionic compounds are solids and are hard because of the strong force of attraction between the positive and negative ions. 2. These compounds are generally brittle. 3. Ionic compounds have high melting and boiling points. Because a large amount of energy is required to break the strong ionic bonds. 4. They are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. They conduct electricity in molten and solution state. They do not conduct electricity in solid state because movement of ions in the solid is not possible due to their rigid structure. Topics deleted from the chapter are basic metallurgical processes, corrosion, and its prevention. Occurrence of metals. Metals are generally found in the Earth's crust. The elements or compounds which occur naturally in the Earth's crust are called minerals. The minerals from which a metal can be profitably extracted are called ores. Extraction of metals. Metals are categorized into 3 parts. I. Metals of high reactivity. 2. Metals of medium reactivity. 3. Metals of low reactivity. The extraction of a metal from its ore involves 3 major steps. Step 1. Concentration or enrichment of ore. Step 2. Extraction of metal. Step 3. Purification of metal. 1. Enrichment of ores. Involves removal of impurities, such as soil, sand, etc. from mined ores. Asterisk. The impurities such as soil, sand, etc. are called gangue. Asterisk. The processes used for removing the gangue from the ore are based on the differences between their respective physical or chemical properties. Asterisk some of the process applied for concentration of ores include gravity separation, electromagnetic separation, froth flotation process, etc. 2. Extraction of metals from their ores. I. Extraction of metals low in the activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar, HGS, which is an ore of mercury, is first converted into mercuric oxide, HgO, on heating in air. Mercuric oxide is then reduced to mercury on further heating. 2HgS plus 3O2 gives to HgO plus 2SO2. 2HgO gives to Hg plus O2. 2. Extraction of metals in the middle of the activity series. The metals in the middle of the activity series, such as iron, zinc, lead, copper, are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, the metal sulfides and carbonates are converted into metal oxides. Extraction of metals from the concentrated ores. B. Roasting. Heating of sulfide ores in the presence of excess air to convert them into oxides is known as roasting. 2ZnS plus 3O2 gives to ZnO plus 2SO2. C. Calcination. Heating of carbonate ores in the limited supply of air to convert them into oxides is known as calcination. ZnCO3 gives ZnO plus CO2. D. Reduction. Reducing the metal oxides to the corresponding metals by using suitable reducing agents is known as reduction. ZnO plus C gives Zn plus CO. The highly reactive metals such as sodium, calcium, aluminium, etc. are also used as reducing agents because they can displace metals of lower reactivity from their compounds. These displacement reactions are highly exothermic. The amount of heat evolved is so large that the metals are produced in the molten state. Thermite reaction. This is the reaction of iron 3 oxide Fe2O3 with aluminium, which is used to join railway tracks or cracked machine parts. Fe2O3 plus 2Al2Fe plus Al2O3 plus heat. Occurrence of metals. Minerals. Elements of compounds occurring naturally are minerals. Ores. Mineral from which metal can be profitably extracted is an ore. For example, sulfide ore, oxide ore, carbonate ore. Metals at the bottom of activity series like gold, platinum, silver, copper generally occur in free state. But copper and silver also occur in sulfide and oxide ores. Metals of medium reactivity, Zn, Fe, Pb etc. occur mainly as oxides, sulfides or carbonates. Metals of high reactivity, K, Na, Ca, Mg and Al, are very reactive and thus found in combined state. Gangue ores are naturally found mixed impurities like soil, sand, etc. called gangue. The gangue is removed from the ore. Metallurgy, stepwise process of obtaining metal from its ore. Times enrichment of ore times obtaining metal from enriched ore. Times refining of impure metal to obtain pure metal. Extracting metals low in the activity series by heating the ores in air at high temperature. Mercury from cinnabar. 2HgS plus 3O2 give to HgO plus 2SO2. 2HgO gives to Hg plus O2. Copper from copper sulfide. Cu2s plus 3O2 gives to Cu2O plus 2SO2. To Cu2O plus Cu2s gives 6Cu plus SO2. Extracting metals in the middle of activity series, metals are easier to obtain from oxide ores, thus, sulfide and carbonate ores are converted into oxides. Metal ore heated strongly in excess of air, roasting. 2ZnS plus 3O2 gives to ZnO plus 2SO2. Metal ore heated strongly in limited or no supply of air, calcination, ZnCO3 gives ZnO plus CO2. Reduction of metal oxide, 1. Using coke. Coke as a reducing agent. ZnO plus C gives Zn plus CO. 2. Using displacement reaction. Highly reactive metal like Na, Ca and Al are used to displace metals of lower reactivity from their compounds. MnO2 plus 4Al gives 3Mn plus 2Al2O3 plus heat. Fe2O3 plus 2Al gives to Fe plus Al2O3 plus heat. In the above reaction, molten iron is formed and is used to join railway tracks. This is called thermite reaction. Extracting metals at the top of activity series. These metals times have more affinity for oxygen than carbon. Times are obtained by electrolytic reduction. Sodium is obtained by electrolysis of its molten chloride. NaCl gives Na++ Cl. As electricity is passed through the solution, metal gets deposited at cathode and nonmetal at anode. At cathode, Na++ E gives Na. At anode, 2Cl gives Cl2 plus 2E. Refining of metals. Impurities present in the obtained metal can be removed by electrolytic refining. Copper is obtained using this method. Following are present inside the electrolytic tank. Anode slab of impure copper. Cathode slab of pure copper. Solution: aqueous solution of copper sulfate with some dilute sulfuric acid. From anode, copper ions are released in the solution and equivalent amount of copper from solution is deposited at cathode. Impurities containing silver and gold gets deposited at the bottom of anode as anode mud. Corrosion. Corrosion, the process in which metals get corroded by action of moisture and acids present in water. For example, times silver reacts with sulfur present in air to form silver sulfide, causing the metal to appear black. Times copper reacts with moist carbon dioxide present in air to produce copper carbonate, resulting in a coating of green color on the metal surface. Times iron reacts with air and moisture from air, due to which it acquires a coating of a brown flaky substance called rust. Prevention of corrosion. Rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing and making alloys. Galvanization. Iron or steel is coated with a protective layer of zinc because zinc is preferably oxidized than iron.